Hey, you already know who it is. It's Estrada here, and our learning target for this video is I can sketch the locus of points equidistant from two parallel lines. All right, let's get right to Locus Theorem 4. So this is the fourth video in our locus series, and we're going to look at Locus Theorem 4. And Locus Theorem 4, you are given two parallel lines. And whenever you're given two parallel lines and you want to sketch the locus of points equidistant from two parallel lines, the result is a line going right through the middle of those two parallel lines. So let's look at example 1. It says, sketch the locus of points equidistant from the lines y equals 3 and y equals -1. State the equation that represents the locus. So let's begin by plotting the given lines. So you're given the line y equals 3 and you're given the line y equals -1. So those are the given lines. This is y equals 3, of course, and this is y equals -1. And we are told to sketch the locus of points equidistant from these lines. So if you go back to our theorem, the locus of points equidistant from two parallel lines is a line parallel midway between them. So the locus of points is a parallel line midway between these two lines. And then it says state the equation that represents the locus. So that will be y equals 1. All right? And that's how you do example 1. What would happen if, let's say, you forgot, locus theorem number, number 4, and is there another way to solve this problem? So let me rewrite this, and I'll take this thing out. So suppose you forgot Locus Theorem 4. What strategy can you use to sketch the locus of points equidistant from these two lines, right? This is y equals 3, and this was y equals -1. So one of the things I've been saying in class is that if you forget any of these theorems, begin by plotting one point that satisfies the locus condition. So in this case, the locus condition is equidistant from the lines y equals 3 and y equals -1. So let's plot one point that's equidistant from these two lines. So that would be one point in the middle, anywhere in the middle, right? So I'll start there. After you plot one point, plot another point somewhere else that satisfies the condition. So could I put a point here? Would it be equidistant from the two lines? Of course, right? It's the same distance from y equals 3 as it is from y equals -1. Right? It's 2 units away from both, so that means it's equidistant from both. Where else can I plot? So after plotting 2 points that satisfies the locus condition, plot another point somewhere else that satisfies the condition. So I can put another point here. I can put, and then you're just going to keep doing that, and then eventually you're going to realize that all along you should have just drawn a line through the middle, and then this line here represents the points equidistant from the two lines. So that's a nice little strategy that you could use if you forget the theorems, right? Just begin by plotting one point that meets the conditions, then plot another point somewhere else that meets the condition, and so on and so on and so forth. So I hope this video helps. Take care.